Welcome back. Apologize for the angle of the screen, but I try to fix it, the worse I make it. So, and I don't want to stand on these chairs with wheels because I don't think that's safe. So I'll see if I can't get that fixed at some point. But I am recording it, so you'll also see it that way. So first of all, highlight where we're at. We finished up chapter 2. And remember, there is the extra credit that's available if you haven't already done it. And my suggestion, if you do it, maybe do it where you have 2 monitors, or at least you can split the screen. As you're watching the video, enter the items from the video, fill out the Google Sheets and with the formulas and such. And that's what that one is designed to do, is to kind of get you prepared for a project we're going to do at the end. The very last part, we'll be using Excel sheets. Last time I waited till the end, and it was a lot harder to teach it. So I'm trying to teach you little things as we go. And if you pick them up, it'll give you more power. You'll still do fine without it, but you'll do better with it. Let's just put it that way. Plus, you get that extra credit. So this week we have slated to do the chapter 3, and what we're going to look at today is just the average, the mean, median, and mode, how data looks. We'll look at a few other things, and then next week we'll have our first exam. So on Tuesday, so a week from today, we'll do reviews, go over some questions, practice tests, so that when you come in for the test, it's not a surprise. You've really already seen a version of the test, so it lets you know what you need to know and maybe what you don't need to know so much. So we'll have that ready for you. And any questions about the course so far? Making good progress. Did a quick look at the grades, and many of you are making progress. Those of you who are not, it's a good time to start making some progress, especially by this weekend to get through everything. So we're going to take a look. And I added this new presentation part. Let's see if it works well. So that, let's see if this works. Okay, so that I can have the calculator on the side. So what I'm going to show you is how to use the NumWorks calculator to do, actually it does it'll do all the calculations for us. So it will give us the answers for what we need. However, I'll also show you how you would calculate it by hand, so you understand mathematically where those numbers are coming from and what they mean. However, once we do it, the feature we're going to use is the statistics feature. Basically, we'll enter our data, and in one fell swoop, the calculator is going to give us the answers to everything for the next 3 days. So today, or 2 days at least, 3 sections. So today we'll talk about what average is, what we call central tendency, and then we'll get to some other features. So first of all, let me give you kind of a high-level overview. So central tendency, what does it mean to be central, in the center? What's another word you would use for that? What's that? Sorry. Balanced. So you're in that middle point, right? Medium. Yeah. That's a type of a center. Mean or average, also a type of being in the center, right? So it's looking kind of at what we would call also typical values. So what does the average college student look like? That's what an average is, right? So it's not necessarily going to apply to everybody, but it's just like if you lump all the data together, it's about where the middle is, okay? And so what we're going to be looking at, if we just say we have our data something like this, today what we're looking is, where is the middle? And we might have, say, 2 different types of data like this. So this is data 1. This is our sample, right? Sample of data. Data 2, data set 2. The middle here is maybe a little bit different. The other thing we're going to look at is from that middle, what is the spread of the data? That we'll look at on Thursday, and these are called like standard deviation, range. There's a couple different ways to measure that spread of the data. With those 2 measurements, where's the center, where's the spread, how spread out is it, we can characterize any set of data. And that's what we'll do. We call those descriptive statistics. So everything we're doing today, descriptive statistics. So we'll describe a set of data and how it's different from one sample to the other. Okay. So remember, we're studying a population group, a large group of people, not always large, but anyway, whatever that population is, we study it by pulling a sample. And each time we pull a sample, there's some randomness. There's, we get what we get. And so those samples can look different, even coming from the same population, right? Because depending upon who actually ends up in that sample, we can get various different data can look a little different. The idea we do with statistics is we pull enough samples, we get a good description of what that data looks like, and then later on we'll learn some tools that will be able to apply that sample, those statistics from the sample, to the whole population. Okay. But the 2 concepts we'll have, so today's concept is just the middle, but we're also going to talk soon about ways of measuring the spread. There are 2 main ways of doing these, and I'll just do that right now. So method 1 will be to look at the mean. We'll talk about what that is, and the standard deviation that we'll look at on Thursday. Those 2 go together, though. When you use the mean, you use the standard deviation. If you're using the standard deviation, you also need the mean to go with it. You need those 2 measures. The mean is where's the middle. Standard deviation is how spread out it is. The larger the number, the more the spread. The smaller the number, it's less spread out. The second way we're going to look at is using the median for the middle. And today we'll talk about how the median is different than the mean. But when we use the median, what we use is what we call a 5-number summary. And something called the range, which is part of it. So the spread is dealt with by the range, smallest to largest, how spread out it is. The 5-number summary also gives us a feeling for how spread out the data is, and the median gives us a measure of the middle. So whenever we use the median, we use the other, median is one of the numbers. There's 4 other numbers that go with it. Again, we're going to see using the calculator, it's all calculated for us, but we'll also do it ourselves so we understand what those numbers mean. The second method, we'll talk about it. It is really location of the numbers. Where are they? The first method is a calculation. So we can calculate the mean, but when we talk about the median, typically we're just locating where it's at. Okay, so those are kind of the difference between those 2. That's the 30,000 foot overview. We'll also talk about the weighted mean. And again, with our calculators, it's pretty straightforward in doing it. So we'll start, well, when we get the pieces of data, I'll actually start showing you how to use the calculator. Now the calculator, you can either download or use the online version on your computer. You can also download it to a smartphone, which I highly recommend because then it works just like a calculator, so that you have it with you all the time. Also works on tablets, iPads, and such. So, and it's available through the App Store. Oh, I forgot when I do this, I have to delete everything. Okay. You can download, just go to NumWorks on either of the app stores, whether you have an Android or an iPhone. You'll be able to download this calculator to your device. So measures of central tendency. Again, what we're looking for is a typical value. And specifically, it's the typical one is sort of the one that's in the middle. So if it's a home prices, we're looking for that value in the middle. What's the average home price? Not the most expensive, not the cheapest, but something in between. What's the most typical? And there's 3 ways to measure that. The mean, which when we're talking about the average, usually that applies to the mean. And simply put, it's you take all the data, add it together, and divide by however many pieces of data there are. Okay, so that's what I mean by it's a calculation. We'll see that one. The median, just like if you're going down the freeway, the thing that's directly in the middle of the freeway is called the median. That's what the median number is. It's the number physically in the middle. Half are above, and half of the numbers would be above, half would be below. So it's a location, not really a calculation. It's what number is physically in the middle. So it requires putting the numbers in order, though. You can't just take a random data set and say, okay, there's 11 pieces of data, so what would that give us? That would give us the number sixth piece of data would be right in the middle. There's 5 below, 5 above. That would be our median, but we have to put the data in order. And finally, the mode is typically most helpful with qualitative data because it's whatever piece of data occurs the most. Okay, so again, it can be done with numerical, but it's not always in the middle. It's just the one that happens the most. So if you went out to the parking lot and got all the colors of the cars, the mode would be whichever color occurred the most. And I didn't really look over white. There's a lot of white cars. There's a lot of black cars and other colors as well. I'm not sure which one would be it, but whichever one happened the most, that's what you'd call the mode. And again, it gives a picture of what's sort of typical, not necessarily what's in the middle in that case. Okay, but those are the 3 measures we have that we deal with. And we're going to start with the mean. And again, the mean is just a calculation. Just take all, you need quantitative data, you need numbers, you add them all together and divide by however many you have. So it's called the average, sum them all together, and then divide by the number of entries. One thing we'll introduce you to is some notation. They use this letter here is a Greek letter called sigma, and it stands for the sum. So whenever you see it in mathematics, typically, I guess it could be used for other things, but usually when you see it, it means take all of the x values, whatever x is, and add them all together. So we're saying that our data is represented by x, and so what this symbol simply means is take the first x, add it to the second x, add it to the third x, and so forth until you get to the very end. Usually they use the letter n, so once you have all your pieces of data, you add them all together, and then what you're going to see is that we will divide it by the total number of pieces of data, which will, since n is the last piece, whatever that is, we just divide by that. Okay. The nice thing is that it doesn't matter whether we have a sample or a population, we do the calculation the same way. We're going to see when we get to variation, there are 2 different ways actually to do the calculation depending upon whether you have a population or a sample, but not with the mean. Okay. So population mean, sample mean, again, same thing, add all the data together, divide by the total number. We use capital N to represent all the number of things in a population, and then we use a smaller case in for how much is in the sample. Okay, but it's just take all the data, add it together, divide by however many pieces there are. Okay, and that always gives us the average. So it's something that you've done probably before. Average things out. You know, I got tips from this, this, and this. We got 3 people. Maybe average. What would be the average tip for those 3 people? So you split things up. That's what we use. Notice the difference of the letters. So this will become important, like in the homework. If they use this letter, it's a Greek letter, and it's pronounced mu, mu, mu. That's the Greek letter mu. That's telling us that that's mean came from a population, right? So that's the larger number. If they use this, what they label as X bar, then that's telling us that this has come from a sample. Okay? And again, when we're doing statistics, it's really important to know whether we're working with the population or whether we're working with the sample, because the calculations are slightly different. Some you'll see, but if we're working with a sample, X bar, population mu. So sometimes it doesn't specifically say in the question, but you have to look by what symbols they're using. Okay, so that'll come in pretty good as you go through. Okay, now let's look at an example. So we have some data here. This is weights in pounds for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? Okay. Now, since again, to calculate it, we would add each of these together. There's 1, 2, 3, 4, 5, 6, 7. So we're going to just add. And you could do it mentally, but there's nothing wrong with using a calculator. And then at the very end, I said there's 7. We would divide it by 7. So since there's nothing wrong with using a calculator, why don't we use a calculator and see how it will do this for us? Now, if you're entering just a standard calculator, a lot of times you'd add, but you lose as you're adding these. You can't go back and check the data. The nice thing about using the NumWorks with the statistics, and again, it works on other calculators. They have these features in there too. I just like this one's fairly easy to use. So you go down to statistics, you hit OK, and this is where we put it. There, it's kind of grayed out a little bit, but it says value. What does it say? V1, and then frequency of that value. So I'm just going to start entering this data. So 274. Notice it just enters in there, and it automatically puts it that it's got a frequency of 1, so it happened 1 time. We're going to see how we can use that frequency to do what's called a weighted mean. Like in this class, homework is weighted at 30%, tests are weighted at 70%. So if we had all your scores, we could actually calculate what would the average be by the weight, and it will do that a little bit later. But all I do is I enter all these in, and the nice thing about this tool is I can come back and check my data as I go through this, right? If I had a calculator, once I entered them, they disappeared. So if I made a mistake, which I often do, I'll transpose numbers, then I'll get the wrong answer, but I won't know it. Okay, so then 223, 268, 290, oops, 223, sorry, enter, 268, enter or execute. Put 265, didn't I? 268, there we go. 290, 285, and then 235. So I'll say the most important thing is making sure you get your data entered in correctly. My dad was a systems analyst, did data processing type stuff, and he would always say garbage in, garbage out. So if you don't get the right values in, you're not going to get the right values out. But as long as you put everything in here correctly, so this gives us a nice, easy way to double check things, especially if you had a long list of numbers, we can check them all. And I'm going to hit this back arrow, and that's going to jump me up to the menu bar. So now I'm up at data, and all I have to do is I go over to stats, and it's going to give me all the values that I need for the next 2 days. Okay, so what we just did, if you can enter that data, you're going to get all the correct answers for this section's homework. Okay, got the data in there correctly, go over to stats, I hit OK. It's given me all the values that I could possibly need. Okay, and we'll show you this. Now, the rest of it is understanding what all these are. So they've got minimum, first quartile, median, third quartile. So this is our 5-number summary. We're going to talk about that next. So I can kind of skip over that. That's not what I want. They've got the range. Again, that goes with the median. So we'll talk about that next. Interquartile range also goes with the median. So these are all when I use the median. But then I've got population mean here. And I've got sample mean. Notice how they have two different, but they're both the same values, 258.57, 258.57, okay? Or you could round it 258.6, whatever they ask us to round it to, right? So that's our mean. And we found it right here, population mean, sample mean. In this case, they're both the same. What you're going to see when we get to standard deviations, though, they have it in here, but the population standard deviation is actually going to be different than the sample standard deviation. That's for Thursday's class. So they add them together. They got 1,810. They divided by 7, 258.6. They rounded it to the 1 decimal place, which is exactly the same thing we got here. So when you're asking for the mean, again, I'm going to have you go into the NumWorks calculator, enter the data, and come over to statistics. And you're going to thank me, especially when you get to the standard deviation. So on Thursday, that's a much more complicated calculation that is really a pain to do if you do it by hand with a spreadsheet, that's okay. But even then, it's better just put the data in and let the calculator handle all the details. But we will talk about how the calculation handles so you can see that that is actually a variation from that mean. Okay, we'll see how it does. But my goal is to get you using the calculation more than doing all the math part by hand. Okay, so that's the mean. Questions? Okay. I could have just said plug it in and there's your answer and let's move on. But I wanted you to see it's an averaging, right? Because we add them all together, we divide by 7, and we could see that this 258, well, if we had it in order, is, yeah, it looks like it's about in the middle. There's some lower ones, there's some higher ones. It's about in the middle. It's the arithmetic middle, okay? The other measurement we use is the median. And again, that's a physical location of what's in the middle. And so to do the median, what you have to do is you have to order it either from smallest to largest, or you could do it the other way around, but we have to have it in order first, okay? And then you divide it in 2 halves, so half above, half below, and whatever's in the middle, that is our median. Now, there's 2 ways to sort of calculate it. If you have the odd number of entries, so like 11, there is a physical piece of data in the middle. Data piece number 6, once you get in order, is in the middle. There's 5 below, 5 above, right? So whenever we have an odd number, it's sort of easy. There's no calculation. When there's an even number, the problem is what's in the middle is a space. And so what we do is we do a calculation as we average the two middle numbers, and we'll see how that's done. Again, the calculator, the numerics calculator will handle all of this for us to get us our answer. But just to understand, when we do the median, this data is not in order. So the first step is to put it in order from smallest to largest. And since there's 7 pieces, there's 3 on the bottom. So there's 3, there's 3, there's the middle number, 268. And since this is the same set of data that we use to find the median or the mean, we come up here to the median. No, it's the maximum. Median right here, 268. So again, you would, in reality, we just put it into the calculator and we're going to be able to find that median. It will find it for us. And if we had a large set of data, especially, that's probably an easier way than getting it all in order, because that's sort of a tedious, can become a tedious process, especially if you don't get something right. We just do that. So yeah, they highlight it's right. It's the one right in the middle. What if there was an even number? So they took one piece of data out. When I looked at this, I'm going to go hit this back arrow. I'm back to my data. They took out 285. I can see that, so I'm going to delete that. Now that there's an even number of data, the way we would go about calculating the median in this case, since there's 3 above, 3 below, the middle would be right here. So they will add them together and divide by 2. We did that with our, remember, with the classes. You take the lower end and upper end, divide by 2, and that gave us the middle point. So that will give us the middle point of 251.5. And since I now have our data, I didn't have to put it in order. I took out that extra piece, hit this back, and I go over to stats. And lo and behold, the median is 251.5. So again, you've got a calculating tool that will find that median for you. You just have to visualize, okay, put it in order. That's what would be in the middle. If I have an even number, if I have an odd number, it's an actual piece of data. In this case, 251.5 is not a piece of data because I had an even number, but it gets us as close as we can get to being the median. So far, so good? Yeah, the median part is, the middle part is not so bad. And we're going to see using this how it's now going to be actually very easy to do a weighted mean, which is actually, again, a fairly tedious process if you had to do it by hand, because we'll talk about it. Finally, the mode is you could use the same set of data. It's the one that occurs the most. And in this set of data that the original set, you can see that there are 2 pieces of data. Well, yeah, 235 and 235 that are the same. And so in terms of the mode, we would say it has a mode of 235. And if we did a histogram, right, that part we would see kind of a bump, right? That would be the highest because it's got a frequency of 2. So that's what the mode looks like on a graph. It's where the big bump is. Okay, so sometimes we use that. It depends on what we're talking about. Sometimes we look at the data, we compare the 3 different measurements, and that will tell us what our overall distribution of data looks like. Okay, so again, we're trying to understand the data. These are just different ways of doing it. So the mode is with quantitative data is not always earth-shattering, but sometimes we use that. Where it becomes more critical is if we have qualitative data. That's really the only measurement we can use, right? Because if we're like, this question is taking people's political party, You can't add a Democrat to a Republican and to an independent and then divide by 3 and get any. You can't take a mean or a median, right? The only thing you can do is look at the frequency. And in this frequency chart, we see that Democrats, for this particular one, are the mode. It's really the only way we can say what's the typical. It's really looking at what happens the most. Okay, so we would say the mode is the Democrats. Independents are close, but not quite. Okay, so mode does come in there. That's the only way we could do it. And again, you could do a histogram, and if you did a histogram, the Democrat bar would be the highest. That tells you the mode. So that's why we do both of those. When you compare them all, the thing is, how do they get affected by the data? So I don't know that we'll put all of these in, but maybe we will. When we use the mean, it's a simple calculation, add them together and divide. And it's a measurement that takes into account all of the data points. So it gives us kind of a picture of all the data. The disadvantage of the mean is if you have what are called outliers. So you have a really big number or a really small number in just one or two of them, but most of the data is like packed here. What happens is that the mean will pull, those outliers pull the mean towards those either lower or higher numbers. Okay, and we'll look at an example of that. So here it is. So if we took the age and people in the class, right? So this might be average, just as a college level class, a lot of 20, 21-year-olds, 22, some 23-year-olds. And here's probably the teacher, 65 years old. I'm not quite there yet. I'm only 63, but that one age we're going to see would take the average away. If you just look without this number 65, you would say probably it averages right around 22, right? 21 or 22, maybe 21.5, whether you use the, however you do it. Again, we could plug it in here to our calculator and it would analyze it. But what I'm going to do is they've done it for us. They'll calculate the mean. So if you add them all together, divide by 20, you get 23.8. Watch how that's different than the median. So you would find the axis is in order. You would see that the median must be about right here. 21 plus 22 is 21.5. So notice how the mean is a little bit higher. That one measurement of 65 pulled the mean higher than the median. And then the mode is the one that occurs the most, mostly 20-year-olds. Okay, so we can see the mean is getting pulled by that one outlier. So one measurement is having a super pull on things. The same thing happens if we look at salaries for a company. Typically the president or CEOs, they make a lot of money. The average worker, not nearly as much as the president or CEO. So and there'll be a homework problem that will look at this. If you take out the president's or CEO's salary, we'd have a much lower average salary. But if you throw in the president's, that brings it up and makes it seem like everybody's making more money when they really aren't. Okay, so that's the difference between whether we use the mean or the median. Same thing if anyone into real estate, I thought there was some people thinking of that, maybe for business. In real estate, they always talk about the median home values because in a neighborhood, somebody could build a huge mansion that's $5 million, and these $400,000 homes all of a sudden would have an average price, if we use the mean, much higher, right? So in real estate, they will use the median. Same thing if you have some just bare land, the median is going to give you a more accurate look at where the average is for home values. And that all depends upon whether there's an outlier or not. So here's it, and here's what the histogram would look like. Here's all the ages of the students. One outlier way out here. And what that does is it pulls the mean towards the outlier. And again, if we had a couple outliers, we could pull it even more. Okay, so it doesn't give as accurate a view of the actual average of the class as the median does. So now the weighted mean. What we need to do is we take each data value and we multiply by the weight of each entry. So that could be the frequency of each, how many times each of those entries are in there, or it could be a percentage, because it, as in grades. So let's see. So notice when we go through this calculation, and I think there's one in the homework very similar to this, the number of credit hours you have affects your, so a higher credit hour will affect your GPA more than one with a lower credit hour, okay? And the way we can do this, show you how you can calculate a weighted mean, is let's clear out this data. It just supposed to be a feature I haven't. It's clear. There it is. So shift, the back button here is the clear. We're going to confirm, clear out our data. So now we're going to put in this data, but to calculate it, we don't use C. We use that a C is worth 2 grade points, okay? And what literally will happen is we'll take 2 times 3, because it's happening for 3 credit hours, and then we're going to do an average based on the frequency, so looking at credit hours as the frequency for the course. However, for our calculation purposes, what we're going to do is a C gets entered as a 2, and then I'm going to arrow over for the frequency. Instead of leaving it at 1, I'm going to put 3 for the credit hours. So you see that this tool is very helpful with weighted means. Otherwise, it's kind of, yeah, you would do it on a piece of paper, 2 times 3. And then this C is also 2 grade points, but it's 4 credits, not 3. So we put in the 4 credits. The D is only worth 1 point. And thankfully, it's only a 1 credit class, so it doesn't weight too heavily. An A is worth 4 points, and it's a 3 credit class. C is again worth 2 points, and this time it's a 2 credit class. And the B is worth 3 points, and it's a 3 credit class. So that what the calculation is going to do is it's going to multiply all of these. Again, this was 2, 2, 1, 4, 2, 3. So all of these get multiplied. You'll get some numbers here. You'll add them all together. And then what you're going to divide by is the total credit hours. So this gives you a sum here. And you can see just kind of calculated, complicated. However, with the NumWorks calculator, as long as we've entered it in here, we come back and we go to stats. All we have to do now is come down to the mean. Population mean and the sample mean are always the same. It tells us we have a, with this grades for say this semester, we have a GPA of 2.5. So again, it's, the thing is it's done it all in the background, and maybe, we didn't know how it did it, but it was important to have those frequencies listed as the credit hours, okay? Because that's basically saying that's the weight of that particular class. So the greater the weight, the greater effect. Again, it gives us the answer, we're done, but what you have to understand is that whenever we do a weighted mean, it's going to need these. You're going to see one in the homework where they use percentages. And so what you do with that is when you put in your data, the frequencies, put in the percentage, but put it as a decimal. So if it's 25%, 0.25, if it's 15%, 0.215, and you just do that so that the total frequencies add to 1, right? 100%, and you'll also get the weighted mean. Okay, so again, a nice tool. That's why I've gone to this one. I believe it can be done with the TI-84, but it's not as easy to do. It's a lot more complicated to add those in. So that's why we're using this. And plus, this is a free one. You don't have to go buy it. You can download it to your phone. You can use it on the computer like I am. You can use it on a tablet. So, questions? Again, they took them all, multiplied to 40. The weight is, notice it's adding all of these. So if you add all these, you get 16. You got our 2.5, which is the same thing we got. But I want you to understand as you're doing things that that's how it's calculating those weighted means. Okay, you've got your data value, but you've got a weight, either a percent or a frequency, just like we were doing the frequency tables. Okay, especially something like this, right? This looks like a really intimidating thing to try to do a weighted mean. However, you set it up, you've got a lot of things going on. For us, we would just need to enter the class midpoints. This is that set of data we had initially. We'd enter the frequencies, and we'd be able to get the average directly from our calculator. It would give us that mean. In this case, you could use a frequency table since we already had it. And notice they take the weighted values of taking x times the frequency, 8,631 divided by 30. So the weighted mean of this set of data is 287.7. Yeah. So it's great if we've already created a frequency table, but then this last column is something new we'd have to add to do it to our calculations. The NumWorks calculator, just enter all the data, enter the frequencies, and then go to the stats, and we'll get our weighted mean. So far, so good? Okay, good. I think we're almost done. Yeah. So there are some shortcuts, but again, you see all the steps involved in using a frequency distribution. You have to find the midpoint, which may or may not have been done. You might just have classes, but in the one we did, we did find our midpoint. You'd have to multiply by the each frequency times the midpoint, add them all together, find the total of all the frequencies, and then you could find the sample mean. With the NumWorks calculator, all we have to do is enter in those midpoints. So we did have to calculate that. We would enter in the frequencies, and again, the calculator would take care of all the calculations behind the scenes. So one other thing you'll need to know is that distributions, this kind of gets back to the theory part, they have various, when we talk about descriptive data, when we do a histogram, they have various shapes. And it won't be till the next section where we get into looking at distributions specifically that this becomes really important, but we'll start with it now. Symmetric distribution is, you could cut it in half and it looks about the same on the left and the right, very close, okay? So that's where our bell-shaped curve comes in. We'll see that that applies to normal distributions. Not all distributions are symmetric, but this one, the left side and the right side look very similar. So you divide it in half and you have that. So there are symmetric distributions. There are what are called uniform distributions. And again, we'll be using all of these. Uniform distribution is all the same um, with basically equal frequencies. Um, so uniform, and we'll do some calculations with this. You'll see that the mean and median are the same value. And if we look back at the symmetric, the mean, median, and mode are all the same value. That's what makes them symmetric. There's not more to one side or the other. So if we have symmetric, we have uniform. What would be something that wouldn't be either of those two? That would be a skew to one side or the other. So this is the one I have problems with because I focus on where the mode is, but what you have to focus on is where are the outliers. So this one is called a left skew to the left, because that's where the outliers are. This is so for me, I always have to remember, I think, I see where the grouping's to the right, that means it's skewed to the left. Okay, so look for where the outliers are, the lower values. Okay, so this is a left skewed. If this is a left skew, what would a right skewed look like? The mode is going to be to the left. There's going to be outliers to the right. And again, since the outliers are to the right, that pulls the mean towards those outliers. So the mean and median are not going to be the same. And we have different ways to deal with each of these types of data. Okay, that's all we can say. So those are the four basic shapes of our distributions, looking at histograms, looking at the frequencies. And again, the nice thing is this calculator, when we get to this part, it will produce these graphs for us really easily. Okay, so we'll see the graphical as well. So right skewed means the outliers are to the right. Left skew means the outliers are to the left. But it is something that is really easy. Get rid of this one. It is something that's really easy to get these two mixed up. Okay. You should say, oh, there's the mode, there's the most frequencies, that's to the left. So we call it a right skewed, or positively, because that's the high end. Okay. And since it won't let me go any further, that's the content for today. So you'll be able to start into chapter 3. Let me see. And I'll post this because I've done this a little differently than the last time I taught this. So that recording won't be as, it'll have the slideshow, but I didn't use the NumWorks calculator. So when we go into the homework, quick look. Mean, median. So again, you'll just put these values into the NumWorks calculator. You'll be able to calculate these readily. Part of it is getting a feel for the difference. Again, we could just put this in. These will find the mean, median, mode. Here's a frequency. So this is going to be a weighted, or actually this one, they just want the mode. So right, it's going to be the one that happens the most. So kind of go through those. Mean, median, mode. The range is and again, the calculator will find this as well. Remember when we were in there, if you go over to stats, it will give you the range. The range is the maximum minus the minimum, but it'll find it for you as well. So all these questions, a couple questions here on shapes, whether they're symmetric, left skewed, right skewed. And then, so question 7 is about the end. We're going to pick up with question 8 on Thursday, talking about standard deviation. You could probably answer question 8 as well. Let's see, actually, let's keep going. 9, standard deviation is one thing that we didn't talk about. So this is actually still mean median. 10, 11. Okay, 11 is where we get. So the first 10 questions, again, are doable. And I like to take things at a relative pace. Let's see what, oh, it's the wrong time. It's 10 o'clock. So we've got 1 hour. And again, you can use the time. You can stay in class, work in class. I'll be here to help you through things. Our embedded tutors here as well. So you've got that assistance. If you want to take a break, that's fine. If you want to head out, that's fine. But the rest of the class period will be a work session. If you have questions from homeworks 1 or 2, this is a good time to get those addressed as well. But just up through question number 10 in homework 3, you'll be able to get that, and that'll get us all set up for Thursday, answering those. Any questions? Okay.